In this example, we're going to find a unit vector in the direction of vector v, and we'll verify that result has a magnitude of 1. So this is going to be kind of a combo of what we've been doing up until this point. Vector v could also be represented as a vector ordered pair with an x component of 6 and a y component of -2. We can get that as the scalar multiples of both I and j here. I should actually include that negative sign there for you. To figure out a unit vector u in the same direction as vector v, but with a magnitude of 1, we'll need to find the magnitude of vector v first. To do that, we're going to square each x and y component here. So we'll have 6 squared, which is 36, plus -2 squared, which is 4, giving us the square root of 40. This can also be represented as 2 root 10. When we write this down for vector u, then, we'll write down the x component divided by the magnitude of vector v. Then we'll represent the y similarly as -2. That's right here. So your 6 was from the 6 of the original vector, vector v. Then the -2 is the y component of vector v. And we're going to divide that still by 2 root 10. If we want, we can simplify a little bit. That's 3 over root 10. And then -1 over root 10. We want to verify that the result has a magnitude of 1. And that kind of looks like a v. That should be a u. So the magnitude of vector u will be the square root of the x component, which is 3 divided by root 10 squared. And then -1 over root 10 is your y component. We need to square that. And we'll add those together and then take the square root. Underneath the square root sign then, 3 squared is 9. The square root of 10 squared is 10. -1 squared is 1. And then the square root of 10 squared we said was 10. So underneath that radical sign, we'll have 9 plus 1 over 10, which is 10 over 10. So the square root of 1 is 1. So this vector u from above does have a magnitude of 1. So it is a unit vector. And if you graph this, it would actually be in the same direction as vector v.